Hello, this is Godwin. Hello, this is Godwin. You're welcome once again to class. This is the second aspect that has to do with LCM. I have done that of HCF recently, which means highest common factors, and we're moving to the next one, which has to do with LCM. This is lesson 2, week 3. It is basically this very one. It is basically first term, basic 1. Why is basic? You can actually use it for basic 2 also. The why is basic 1 is because the kind of example used, the figures used are not that huge. Just something that can easily be broken down into smaller bits. But you can, in the same understanding, applies to basic 1, basic 2, and basic 3. So, what is lowest common multiples? The lowest common multiples of the 2 or more numbers is the lowest multiple they have in common, right? So now let's work on example. Find the LCM of the following. So what we need to do is now you will start dividing by using the lowest prime number. Now I want to work on this 4, separate it to the comma, and then 6. So start with the lowest prime number. You keep dividing. Once it cannot go, you move to the next prime number. So 2 in 4, we have 2. 2 in 6, we have 3. So 2 can still go, can still use 2. 2 in 2, you have 1. 2 in 3, it cannot work because it will be having a remainder, and once it's having a remainder, don't divide it, just drop the figure, drop it. So you move to the next, you continue, you use 3 because that's the one that can go. 3 in 1 is still 1. 3 in 3, you have 1. Are you following now? So now you multiply all of this to get your LCM, which is what the question says. That is 2 times 2 times 3. So what will it give? 2 times 2 times 3. At the end of the day, you have 12. So that is how to go about it. All right, let's move to this other one. The next example has 3 has comma 6, and have comma 10, have a comma 18. So we are looking for the LCM of these 3. Start with the lowest prime numbers. So 2 in 3 will have 1 remainder, so you don't do anything about it, you drop it, you drop the 3. 2 in 6, you have 3. 2 in 10, you have 5. All right. 2 in 18, you have 9. So what else are we going to do now? 2 cannot go again. if the 2 goes, it will have in a remainder, so you go to the next prime number. You see, I started with prime number 2, so start with the lowest prime number. So I move to the next prime number 3. 3 in 3, I have 1. 3 in 3 again, I have 1. 3 cannot go in 5, you drop it. 3 can go in 9, I have 3. So I can still use 3 again. I can still use another 3. 3 in 1, 1. 3 in 1, 1. 3 in 5, it cannot, it will go, it will have a remainder, you drop it. Number 5. 3 in 3, have 1. So 3, if you use 3, this 5 is going to have a remainder, so you use 5. 5 in 1, 1. 5 in 1. 5 in 5, I have 1. So I need to come back. Something, okay, I need to erase this. It's not that okay. Let me come back to her. So 5 in 5 in 5 have 1. 5 in 1. So you now, the LCM of all of this is now simply saying 2 times 3 times another 3 times 5. Are you following? Times 5. At the end of the day, your answer will be 90. So the LCM of this very figure is 90. Any question? Let's go on. The next one is simply saying the difference between the LCM and the HCF. Yes, LCM and the HCF. So now, how do we go about this? You will first of all find the LCM and you find the HCF of both numbers. Whatever you have at the end of the day, you subtract it. That is what the difference they are talking about here. So let's start with the LCM of 48, 72. So you start from the lowest prime number. So you start from the lowest prime number. If I want to do that of the LCM of these two, so 2 in 48, I have 24. 2 in 72, I have 36. Are you following? 2 can still go. 2 in 24, I have 12. 2 in 36, I have 18. 2 can still go again. 2 in 12, I have 6. 2 in 18, I have 9. So you keep doing it until it is no more. So 2 can still go. You can still have 2 here. 2 in 6, I have 3. 2 will go in 9 and it will have a remainder. You drop it. So I now have 3. 3 can go without a remainder. 1, 3 in 9, you have 3. Then you have go again, 3 in this is 1, 3 in 3 is 1. So the LCM is now 2 times 2 times 2 again times another 2, right, times 3 and times 3, the last one. The total answer, if you multiply them, you'll be having 144. This is for the LCM. This same value, you do it for HCF also. You do it for HCF, right? So you have 48, right, comma 72, right? All right, 72. So start with the lowest prime number. 2 in 48, you have 24. You have 2 in 72, you have 36. 2 can still go, so 2 in 24, you have 12. 2 in 36, you have 18. 2 can still go again. Once it cannot go through the two of them, you stop there. 2 in 12, 2 in 12, I have 6. 2 in 18, I have 9. All right, 3 can go. 3 can go, and it will affect the two of them. 3 can go. 3 can go. So I have 3 in 6, I have 2. 3 in 9, I have 3. Now in this one, I have 2 and 3. Nothing can go with the two of them. If you use 2, it will affect these 2, it will not affect them. If you use 3, it will affect 3, it will not affect 2. So the HCF have to stop here. So the highest common factor, it is now 2 times 2 times another 2, the 2 that is there, and then times 3. So this figure will give us 24. Now the question says the difference between the LCM and the HCF. What it simply means is 144, right? 144 minus 24. So the answer is simply, let me write this one very well. So 144 minus 24 is simply 120. It's simply 120. So the difference between this is 120. So you can have this as you can use this as a practice exercise. It's a practice exercise. Find the HCF and the LCM of all of this. Number 1, 40, 60, 90. Number 2, 45, 54, 180. And then the next one says, number 3 says, find the difference between the LCM and the HCF of the numbers in question 1 and 2. So find the HCF of this, find also the LCM and subtract it. Do the same for number 2. So I want to stop here. Please subscribe, click like buttons, share my videos. Thank you so much. for listening. See you once again some other time. Bye bye.